Hello students, today we will study some of the theorems of this chapter. This is the chapter of standard 9, chapter number 6, lines and angles. So here we have to study the theorem 6.3. What is the statement? The statement is if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. Now focus. Here we have given that if a transversal intersects the two lines, here we do not have said that the two parallel lines. Here we have said only the two lines. Now what will happen if a transversal intersects the two lines? If the pair of alternate interior angle becomes equal, then we can say that both the lines are parallel. Now see, if we have given that AB and CD, these two lines are, first of all, we do not have given that they two are the parallel. But if this pair of these angles, now we can see that these two angles are making a pair of alternate interior angles, that is angle BQR and angle QRC. Both these angles if equal, then we can say that both the lines AB and CD are parallel to each other, right? So it is not necessary that both these pairs must be equal. If the angle AQR, if this angle will become same with this angle, that is AQR is equals to QRD, this also making the pair of alternate interior angles, then if both these angles are equal, we can say that line AB is parallel to line C. When we can use this theorem, where we have to use this theorem? We have to use this theorem when we have to prove that the two lines are parallel. Whenever we have to prove this thing, we can use this theorem, right? At that time we have to prove that alternate interior angles are equal, right? Okay. Now let us understand the theorem 6.4, that is if a transversal intersects two parallel lines. See, notice this. Here we have given the two lines only. Here we have given the two parallel lines. Okay, two parallel lines. Then each pair of interior angles on the same side of the transversal is supplementary. Now what is the meaning of this supplementary? That we have studied before. If the two angles, if we add and the total will become 180, we can say that both the angles are supplementary. And what will happen if the addition of the two angles is 90 degree? We can say that they are two angles are complementary angles. So here, if we have said that AB is parallel to CD, that we have given. Here this thing we have given. Then what will happen? Each pair of interior angles on the same side of the transversal. Same side of the transversal. That means this is the PS is the transversal. Either we have to take the left hand side or we have to take the right hand side. So if we consider the left hand side angles, so here we can take the angle AQR, angle AQR and QRC, angle QRC. They both, if we add, we get the 180, because both these angles are making a pair of supplementary angles. In the same way, if we consider the right hand side angles, so right hand side we have angle BQR, angle BQR and QRD, angle QRD. Here also if we add both these angles, we get the 180 degree, because both this angle and these angles are making a pair of supplementary angles. Understand? Okay. Now let us understand the theorem number 6.5. The statement is if a transversal intersects the two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. So this theorem is the converse of this theorem. In this theorem we have given that if the two parallel lines, here we have given that a transversal intersect the two parallel lines, then both these angles are become the supplementary. Okay, we can say these two angles as a co-interior angles, right? Right hand side co-interior angles, and these are the left hand side co-interior angles, and these two angles are the right hand side co-interior angles. So this theorem is converse because here we have given just the two lines. We do not have given the two parallel lines. So what will happen if the two angles will become equal? Sorry, if the two angles will become the supplementary, then the two lines are parallel. So this is what the converse of this theorem 6.4, right? So this is theorem 6.5. Now let us study the theorem 6.6. So here in this we have given that lines which are parallel to the same line are parallel to each other. Here we have given the three lines L, M and N. Now here we have given that line L is parallel to M and line L is also parallel to line N, right? Now line L is parallel to M and line L is also parallel to N. Then we have to say that these two lines are also parallel to each other because both these lines are parallel to the same line. That means these two lines are also equal. See, from L parallel to line M, if the line L is parallel to M, then according to the corresponding angle, we can write down that angle 1 is equals to angle 2. Right? This is according to the axiom, corresponding angle axiom. Both the corresponding angles are equal if the two lines are equal. In the same way, L is also parallel to M. So this 1 and 3 are also the corresponding angle. So we can write down angle 1 is also equal to angle 3. Now if we compare both this, we get that 1 is equals to 2, 1 is also equal to 3. So angle 2 will become equal to angle 3. See, both these angles are also equal. Now according to the converse of this corresponding angle theorem, if a transversal intersect the two lines and corresponding angles becomes equal, then the two lines are parallel. So therefore we can write down here line M is parallel to line N. Right? Line M is parallel to line N. So here using the corresponding angle axiom and converse of the corresponding angle axiom, we can prove that the lines which is parallel to the same lines which is parallel to the same line are parallel to each other. Okay, so this is how we can prove this theorem. So this all the theorems 6.3, 6.4, 6.5 and 6.6 are very important, right? Whenever we have to use all this theorem, that we have to think, understand. Whenever we have to prove that two lines are parallel, then we can use this theorem 6.5. We have to show that both the interior angles on the same side of a transversal are equal, then both the lines are equal. Then both the lines are parallel. In the same way, this theorem is also we can use if the both pair of alternate interior angle is equal, then we can prove that the two lines are parallel. So both this theorem 6.3 and 6.5 we can use whenever we have to prove that two lines are parallel. Okay, so this is all about this lecture. Thank you.